So our today's topic is resistance welding, and today, 2nd of September 2020, we will discuss on resistance welding. The basic working principle of resistance welding depends upon the formula H is equal to I square RT, where H is heat generated, I is the current flow, and R is the resistance of the circuit, and T is the time period. So controlling these three variables I, R, and T, we get heat, and with that heat we uh, change the state of the workpiece into a plasma state. The solid state changes into plasma state, semi-liquid state, and then we allow it to solidify or cool down, and then it solidifies, and thus the joint is produced. Now here, if we draw the block diagram, it seems there will be two electrode. Between them there will be two job. These are the two electrodes. Now these two electrodes are going to get attached with a power supply. It might be AC or might be DC. Most of the cases AC is used. Now this power supply again connected with a timer.
Sir, someone is waiting outside, sir.
No one is waiting. Okay, so this is the timer block, and these two terminals are the AC supply. How can we find out this is AC supply? Because there is a transformer. So this one is transformer. Okay, so this is the block diagram of resistance welding. Okay, so if it is asked the definition of resistance welding, we will say resistance welding is one of the type of welding process wherein the coalition is produced by electrode, and the heat obtained from the resistance of the work in the flow of current in a circuit in which work is a part, and by application of pressure. So resistance welding is used by the application of pressure as well as application of current. Both are required. So this is a kind of pressure welding process, and as well as electricity is required. So there are different uh, components, the equipment. We'll uh, learn one by one. So initially, a machine, normally you have seen in the job shops, are look like this. There is a cover. Let me draw the figure. There is strong manifold. Here are two terminals. One goes to current control system, and it goes to transformer. And this secondary circuit is connected to different electrodes, and this other terminal is connected to a circuit breaker, which is new here. and this circuit breaker, circuit controller, is again connected with a timer, and that timer is again connected with a foot lever. So this is transformer, this is main supply. If the working principle of resistance welding is asked, then you have to draw this figure. So here this is electrodes, and these electrodes here again is connected with a air cylinder. To apply pressure. So this upper arm is movable and lower arm is fixed, and these two electrodes are uh, either copper made or copper chromium made or
Sir, what is the name of that cylinder?
এয়ার সিলিন্ডার, সিম্পলি এয়ার সিলিন্ডার, যেটা নিউম্যাটিক ভালভ হিসেবে কাজ করবে, নিউম্যাটিক সিলিন্ডার হিসেবে কাজ করবে। That if the compressed air pushes the cylinder, the piston, then this electrode goes down and presses the workpiece. Or copper cadmium. Now then this I means it controls current, F means here foot switch, which uh, initiates the current transfer, or uh, it is also connected with the air cylinder. Now when you press the foot pedal, then initially first the compressed air moves the piston, and the upper arm or the upper electrode gives pressure to the job, and when sufficient pressure is achieved, then current flows, and then the circuit breaker breaks the current, and then these electrodes squeeze, মানে keep the pressure same, that is called squeezing. At that time no current passes but the pressure remains same, and the plasma metal or semi liquid metal between the two surfaces of the job gets time to get solidify, get cooled, and then when we release our foot, then the pressure goes away, and then we take out the job. This is the principle. So F is foot pedal, C is the contactor which controls the contact, and thus uh, this controls the on off of the current, or we again call it circuit breaker also. L is the flexible leads which are used to connect transformer to electrodes, and this I is already discussed. TR means transformer. Okay, so this is the diagram which you have to draw if the working principle of resistance welding is asked and the number given is quite high, then you have to draw the diagram. or you just draw the diagram, because the diagram is the everything. Now, for higher productivity or higher duty cycle, you need to provide cooling water through the electrodes. Otherwise, the electrodes will be get heat, and your production will get uh, face less time, less manufacturing lead time. So the variables here which you have to know, which the operator have to know, is current. Current is very important criteria, because if you increase the current, then your sheet metals or your jobs which you are going to be resistance weld, that will liquefy from top to bottom. The whole thickness will be wipe out. So joint will have to produce you will get a hole instead of a joint. And if you provide less current, then the joint strength will be less, and there is a chance that no joint uh, will form. So you have to choose current very carefully. The resistance is not much to control here. The time is also very very important criteria. You have to provide a fraction of second uh, through which the current will pass. As because if the time is given higher, the heat will produce higher, and the sheet will be uh, become hole in the sheet. When you try to join, the sheet will be punched, and the pressure also. You have to apply so much pressure that the joint should not move, and the resistance becomes lower. Correct contact to be made. Otherwise, uh, it will become very difficult. And if we apply more pressure, then the surface will be ruptured. The job material will get a shape of the you know tip of the electrode for high pressure. Pressure to be controlled also. Now for current, uh, normally we use AC, but DCs are also used, mostly used AC. You need to use a step down transformer to reduce voltage and get higher current. The current is controlled through the taps on the primary circuit of the primary coil of the transformer. Okay, so current is controlled. If you look at the image which we have drawn here, if you look here, you'll find the controls are attached with the primary coil of the transformer, not the secondary one, on the primary one. The current is controlled in primary coil. Low current will not provide proper fusion. If the current is too high, the entire thickness of the work metal between the electrode is heated to the plastic state by the time. Now, in case of normal uh, resistance weldings, single phase AC 50 Hz current is used. But for seam or continuous welding, high frequency is used. Now we talk about resistance. There are three types of resistance working in the region. First one is resistance of the workpieces.
কিসের জন্য হাই ফ্রিকোয়েন্সিটা ইউজ হয়, কোন বিল্ডিং এর জন্য আরেকবার একটু
Seam
দেখাতে পারবেন?
welding, continuous spot welding
ওকে
or
স্যার,
seam
ওকে
welding.
স্যার, ওকে স্যার, থ্যাংক ইউ।
Okay. Number two, the contact resistances between electrodes and workpiece. Contact resistance between electrodes and workpieces. So upon providing higher pressure, this resistance lowers. Okay. Now the third one, the resistance between the two mating surfaces of the workpieces, and this is called R2, this is called R3. This R1 plus R2 plus R3 is the total resistance which are working in this case.
স্যার R1 আর R3 এর মধ্যে ডিফারেন্সটা কি তাহলে?
R1 টা হচ্ছে resistance of the workpiece, okay? R3 টা হচ্ছে
অফ আ সিঙ্গেল ওয়ার্ক পিস?
না, both workpiece, দুটো ওয়ার্কপিস আছে, দুটো শীট আছে, দুটো শীটের দুটো রেজিস্ট্যান্সের
ইয়েস স্যার,
যোগফলটা হচ্ছে R1, আর R3 হচ্ছে
ইয়েস স্যার, বাট ইয়েস স্যার,
কন্ট্যাক্ট
ইয়েস স্যার,
রেজিস্ট্যান্স, কন্ট্যাক্ট রেজিস্ট্যান্স যেটা দুটো, মানে দেখো কারেন্ট যখন একটা সারফেস থেকে একটা সারফেসে জাম্প করছে তখন এই মাঝখানে একটা কন্ট্যাক্ট রেজিস্ট্যান্স থাকে, বিকজ
ওকে স্যার, ওকে স্যার, ওকে স্যার,
বিকজ two surfaces are like this. Actually,
ইয়েস স্যার, ইয়েস স্যার,
surfaces are not like this. These are not plain. These are rough like this. So this contacts the number of crests, then the number of peaks depends. These are three.
ইয়েস।
Okay. So the shape and size of the electrodes and the pressure exerted on their matter. These matters on R2. That means if we apply more pressure, then this R2 will decrease. R3 may also be also decrease, and the shape and size, these also works on R2. If these things goes higher, the shape and size goes higher, and the pressure also goes higher, the R2 decreases sufficiently. The electrodes are made of highly conductive material, as I discussed earlier, such as copper cadmium and copper chromium. In such case, the electrode will be highly conductive and the electrode will not receive much heat. The workpiece will receive much heat. Our objective is to heat the work, not the electrode. So that's why we will need to use the higher conductivity electrode materials, which are basically electrode should have higher conductivity, like copper cadmium, copper chromium. These are of course alloys. Now the shapes of the electrodes are several types. Shapes of electrodes. There are three types: flat, flattened like this type. Number two, truncated type, which are like this. This shape is called truncated type. Number 3, spherical type. Spherical type means the end is like this. Spherical end. Now we need to know about the time period or the duration along the welding. So this time are divided into 4 segments. Four segments. The first one called squeeze time. The second one is weld time. Third one called hold time, and fourth is called off time. Now we'll try to uh, express these all times through a graph. Let us start. Along these is current. Along these is time. Now, when the electrode is not touching the job, in this case, okay, upper electrode is not touched, then it will be off time. Okay, initially it is off time. Then, after the electrodes been touched, the pressure starts to build up. So pressure rises up to a certain value. When the pressure rises, the current is not yet given. Okay, then so pressure increases. This is actually not current, this is pressure. So pressure increases in squeeze time. This is called squeeze time. Okay, now in this region the pressure kept constant and the current passes. The current passes and the pressure kept constant. So this is called weld time. Pressure is fixed and current passes. So if I show the current here, the current will look like this. So this is the current value. Current is work upon only this time. Now then, after that, the pressure slowly decrease, and here after the current is passed, we are decreasing the current. This is, there is pressure sign to be shown with the arrow. here also the sign to be shown. Now the pressure slowly decreased, and later on, at the time here, the pressure totally uh, is taken away, but still they are in contact. After that, the contact of the upper electrode is taken away, electrode is lifted up. This is again off time, and the job produced here, and this is the weld nugget. This is called weld nugget. This is the joint actually. So the current between these two mating surfaces produces this little very small joint. This is called weld nugget. So when the pressure got down and the welding is stopped in this region, this is called the forge time. Forge time or cool off time.
Post time, sir. Post time is not in this sequence, sir.
Forge time is
Sir, in the fourth parts, there is no post time.
in the fourth part. 1, 2, 3, 4. The fourth time is the forge time. What is your question? Please tell me again. I cannot understand.
স্যার আমাদের যেটা চারটা ভাগ আছে টাইমের,
Hmm.
ওখানে তো স্যার পোস্ট পোস্ট টাইমের পার্টটা তো নেই। ওটা ওটা কোনটার
No, no,
বোঝাচ্ছে যে
no.
ওখানে পোস্ট টাইম?
Off time is the first. Okay. In this time, we just set the object. We take out the uh, already produced jointed part and give the new part in the off time. Okay. Then we provide squeeze after joining the fresh workpieces. Then we squeeze it. Then we pass current. Then we keep the pressure, but we reduce the pressure but stop the current. That is called forge time. And then when
স্যার
forging is,
পোস্ট টাইম মিন্স হোল টাইm?
yeah, whole time. Forge
ওকে,
time and whole time is, no, whole time actually, these two are actually whole time. The whole time in the first segment weld happens, second segment weld does not happens, only solidify occurs. So this is you may call cool time.
ওকে স্যার, ওকে স্যার, থ্যাংক ইউ স্যার।
When the heated workpiece get cooled but under pressure, then it is called forge time. Then again off time starts. So basically the cycle ends here. So you see there are only 4 segments. Now again when you try to collect your job after completing the weld, then again off time comes. So off time basically loading time, loading unloading time. So you may consider one cycle and there only single off time is to be considered. Means last off time will go into the next cycle. Am I clear?
ইয়েস স্যার।
Okay. Okay. Let's go on next topic. So you have to understand from this graph how the pressure is varying, how the current is varying. So I'll better write them down so that you understand point wise in a very brief manner. Squeeze time is time between initial application of the electrode pressure on the workpieces. Number 2 is the weld time.
পেজটা একটু স্যার ক্যামেরা বাইরে চলে গেছে।
Oh, sorry. Okay, now oil time. So during this stage, the current flows through the circuit from electrode to the workpieces. So this time we just write current flows. I am writing it very short, but that doesn't mean when you're writing in exam, you write just current flows. You have to write from where to where, how the current is flowing. Just you need to complete the whole line. Okay, whole time, or you can call it forge time, or you can call it cool time. Okay, so here no current passes, electrode pressure remains or decreases, and cooling or solidification of joint or weld nugget occurs. Okay, and number 4, off time. So this is the time when electrode lifts up and job loading or unloading is done. Now we go for the advantages of resistance welding. We'll discuss advantages one by one. The first advantage is no filler rod or electrodes, extra electrodes actually, are required, because the electrode here used is non-consumable and it works several years, and no filler rod is also required. Very high rate of production can be achieved, and semi-skilled operator can perform very well. Semi-automatic equipment, you just need to fix your variables just one time, and later on it will continue on the same setting. No part warping or distortions, no need of edge preparation, but if the object is rusty or greasy, then it's better always to clean out all those rust or dust or grease if there is any. Now less
স্যার 5 নম্বরটা একটু বলবেন স্যার?
5 নম্বর হচ্ছে no part warping or distortion. Do you know what
ওকে
is
স্যার।
warping?
There's some cracking
Not just
warping.
cracks. I mean, uh, when you heat something and cool unevenly, or you apply pressure unevenly, then you get the job. If it is very thin, it gets, get wrinkles on it. That is called warping.
Okay, sir.
So less chance of workpiece burn through. If the workpiece burn through occurs, it will occur only single time. So you just change your parameters, and then every time you weld, the workpiece will not burn through, because the circuit breaker will remember the time and the current value. So whenever the time passes, the circuit breaker will stop the current, and the heat generation every time will be same. Okay, number 8, less time consuming process. Number 9, it is suitable for mass production, as it is very simple, requires very less time, and no metallurgical changes in workpiece. This is very advantageous, that there is very small, or at least, I mean, almost no metallurgical changes occurs, because the heat affected zone is very less. Okay, give me a minute, I have a phone call to attend. Or we can end up here for today's class.